chapter, we will discuss the restoration design. The most common method nowadays is the digital process. The CAD CAM has been introduced to the dentistry since the early 80s, and this technology has automated some of the more mechanical and labor-intensive procedures like waxing, investing, wax elimination, casting, and pressing. These, although they are until now being done in the conventional method, but the digital method is becoming more common, where the analog laboratory process of hand waxing has evolved into digital waxing. Also, these types of software has enabled us to do virtual articulation via digital occlusal registration in this method to evaluate the interocclusal relationship. After a file is created where we write the patient's name, the dentist's name, and the tooth number, the type of the restoration, some proximal contact tightness preferred, occlusal contact strength, and a virtual die space thickness, which will define the internal fit of the restoration, because this space will be filled with the cement. Second step is the insertion of the casts of both the maxilla and the mandible. There's two ways. The first is using an intraocular scanner that we scan the arches directly from the patient mouth, and we take the occlusal relation, scanning it when the patient is occluding. The other method is by scanning the casts like this, individually and in the interocclusal relationship. The software chooses the tooth shape via a library that is being designed inside the software that is based on scanning thousands of natural teeth and denture teeth. There is a way of doing a primary design of the restoration called the cloning. How is it made is by replicating the contralateral anterior teeth. For example, in this case, the maxillary right lateral incisor will be cloned for the restoration of a left lateral incisor. We will clone this by this. We first mark the outline of the teeth that we want to be replicated or cloned. Then we see that we got a definitive design of the lateral incisor tooth that replicates the shape and the details of the other contralateral teeth. Also, it can be done for the posterior teeth by doing a contralateral posterior cloning to get this accurate result. These types of softwares has provided us with these huge libraries of the different designs of the morphology of the teeth that is based on more years of experience and so many combination of natural anatomic morphology. Also, for example, they treat the teeth by sections. For example, the anterior tooth shape is divided into 9 distinct shapes. Each tooth has 3 planes and 3 shapes on its labial surfaces. It can be convex, flat, and concave with different tooth shapes. So it can be round on the mesial, round on the distal, square on the mesial, square on the distal, and square in the mesial and the distal. Like this. There is so many different configurations that can be done. After the occlusal adjustments, and when we choose the incisal shape, we must now do a confirmation about the occlusal contacts of the opposing teeth. First, the computer has placed the restoration in the most appropriate position based on all the input, and it can be modified by the operator's experience and knowledge to manually position and contour the restoration to the functionally preferred shape. Then, an automated function of most software is designed to propose a fossa point contacts on the appropriate triangular ridges with a virtual auto adjustment tool. This can be easily modified to provide a different design, such as the occlusal fossa contacts with broad flat holding areas for the opposing cusp tips. The position on the intensity of each contact point are graphically demonstrated and color mapped immediately on the screen and can be adjusted pending operator and clinical preference. Here we can see the occlusal marks where they have been smoothed out and readjusted to get rid of these contacts occlusion marks. Using an array of virtual carving and waxing tools, we can customize and show the artistic and creativity of the possible morphology and details that can be done that mimics the traditional laboratory methods and armamentarium. After all the details has been done, the proximal surface contacts, the incisal shape, the interocclusal contact points, the basic convex and concavity shape and the contour. After all of this has been done and designed, we give the order of milling or printing. Milling is the passive, which means that we get the shape from a block, but the printing is the gradual building of the teeth. They are saying if we choose the milling, a block of material of selected shade, ceramic or composite resin is placed in the chamber of the milling unit, and it takes about 15 minutes to generate a replica of the digital design. Here, the used is a zirconia restoration from a block, and it is the milled. After the milling, finishing and polishing is made by conventionally using staining and glazing techniques appropriate for the ceramic selected. This is before the finishing, and this is after. The great advantages of this advancement method of digital design and milling. The traditional method is still used, and we should take a brief explanation about it. It is actually a historical method that dates to the Bronze Millennium, 2700 BC. It was used for the jewelry manufacturing, and until now it is used in jewelry manufacturing. Also, the beeswax and the clay refractory materials were used in the ancient times by the Chinese, the Egyptians, the Greeks, and the Sumerians. Also, they used this method of the casting by doing the shape first using a wax, then it goes to a funnel and the wax is melted and filled by the material instead. We will see the process in detail. It must be noted first that after the solidifying of the metal, when it cools to the room temperature, it shrinks. To compensate this shrinkage, the dimension of the waxing should be a bit larger than intended. So we get, when after the baking or the casting, it goes to the appropriate dimension that we want. So it really depends on careful handling of the wax. So here, after we took the impression and do the cast, then trimmed it to get the dye, the wax pattern has been built over the dye. Then a sprue is attached to the wax pattern, and it is melted, and a casting is inserted where a metal is inserted, and we got the final restoration. The first step is blocking out the undercuts using a resin dye spacer. It is available in contrasting colors to facilitate the applying of the number of coats. It must be kept 1 millimeter from the margin. We do the dye spacer step is because it is the space of the cement in the future. It should not coat the entire preparation, and it should not be so thick, which will result in excessive thickness of the spacer. We must make sure that it maintain a constant thickness when painted on the dye. Then the dye is ready for the waxing. The wax is made of paraffin by 40 to 60%, and some other materials like the carnauba, silicene, candela wax is incorporated to raise the melting temperature, or beeswax is added with the dyes, and some synthetic wax is substituted for the natural material if it is not available. We have two types of the wax. The first is the medium hardness wax that is used with the direct technique for making patterns in the oral cavity. The type 2 is the softer wax where it is used for the indirect fabrication of the wax. Also, there is a reason for the distortion in the wax, that it has a memory, which means that it exhibits some elasticity when it is liquefied until it is thoroughly liquefied. To overcome this problem, the initial layer of the wax is applied in melted increments or drops. An alternative method is to make the initial coping by dipping the dye into thoroughly melted wax. We must make sure to not increase the concavity and the bulkiness of the axial wall. These are the adamantium that are used for the carving and the burnishing. We usually use the heat, but there is an electric waxing instrument that aid in this process, where the melting is done by an electric current, and there is a wax dipping pot that we can adjust the temperature and put the wax in here, where we first, after applying the lubricant to facilitate the removal of the wax after we finish the waxing, we dip the dye inside this waxing dipping pot, and we should not begin the dipping until the lubricant has been allowed to soak in completely. Then we start building the proximal surfaces to mimic the natural teeth. In natural teeth, the surfaces are not convex. They tend to be flat or slightly concave from the contact area to the cemento enamel junction, and any restoration must reproduce this feature. If we over-contoured, it will make the periodontal health difficult, and if we made an under-contoured proximal surfaces, it will make the flossing inefficient, and so this must be avoided. When we evaluate the waxing, we must not have folds and crease, which indicates that the wax was not hot enough when applied. Waxing the proximal surfaces is so important to have the contact area that mimics the natural teeth. When we see that, we must maintain the triangular shape of the posterior embrasures. The contacts areas on the maxilla, as we go from the to the anterior area, the contacts become more occlusal, and in the mandible, when we go posterior, it become in the central. This is between the mandibular molars. When we go to the contacts between the premolars and the molars, the contact become toward the buccal surface, and the proximal surfaces should be flat or slightly concave. A common mistake is that the increase of the bulkiness of the restoration in the buccal surface. So, to ensure the proximal contacts are deficient, a slight amount of stone is scraped from the adjacent tooth before waxing, and then the wax is added to the contact area to establish a correctly located proximal contact. After finishing the proximal contacts and the axial walls, now we should go to the occlusal surface. It is usually done with sequential wax addition technique, and it is useful to build the composite in the same way. We first do to develop an accurate occlusal contacts. First, the wax is added in small increments, and the articulator is closed while the added wax is still soft. Cones are used to determine the location of the lingual cusp tips. Then the various features of the occlusal surfaces are developed sequentially in wax. We do burnishing and re-establishing of the shape. Then we mark the occlusal contacts to evaluate the intercuspal occlusion, where we have a cusp marginal ridge occlusion, tooth to teeth, and a cusp fossa occlusion, tooth to tooth. So the waxing starts from the borders. We place the cones in the position of the cusps, and then we go inside until we reach the central fossa, where we build the cusp gradually to get the final occlusal waxing. A note that the mandibular cusps should become taller farther distally as we go, and the maxillary cusp should become shorter. Why we are doing this is to follow the curve of Spee and the curve of Wilson. So we add wax cones to determine the cusp height and their location to get the appropriate height. We mark the central fossa of the opposing teeth to help position the functional cusps correctly. These are the triangular ridges. The final wax pattern must be smooth. Then we add the sprue to it. After we examine any deficiencies, and we do an adjustments to it before the casting stage and do the casting where we add the metal. Here they are saying that an additive wax pattern can be printed in the new dental technology, but I don't know the need for it, where we can design and then mill it by the laser. Here it is printed by additive procedure, where it is built layer by layer, or it can be milled from a disc. To sum things up, the first step is lubrication, then initial coating of wax, then the proximal surfaces are developed, then the axial surfaces are waxed, then occlusal surfaces are developed. Waxing up teeth from memory is not advised. Even the most experienced technicians should copy the shape of natural teeth rather than redesigning them. That's it. Salam.